Okay, so when dealing with small angle approximation, sometimes we are interested in knowing what's the percentage error. So we have the actual value and then the approximated value, right? So what is the percentage error? And this could be easily be found by using this formula. Percentage error equals to the modulus of the actual value minus the approximated value over the actual value times 100%, okay? The reason why we have the modulus is because we're not interested in the sign, okay? That means we're not interested whether, you know, the approximation is larger or smaller than the actual value, because if the case, in the case of the approximated value being larger than the actual value, this without the modulus would be negative, right? And then we get a negative percentage error, but we usually don't want to have that, okay? We just want to know in either side of the true value, okay, what is the percentage error, okay? So how many percent away from the true value. Now, let's take a look at some example, okay? So we'll look at an easy one first. Let's say we have just cosine x, okay? We'll use this cosine x. We know it's approximately equals to 1 minus x squared over 2 factorial, okay? Then, I know 2 factorial, okay, but I prefer to just write 2, okay? It's the same value. Now, with x, okay, we can choose an x value which is sufficiently small. Let's say when we choose x to be 0.1, we can go ahead and figure out what is the value of cosine x, okay? The true value, okay? So that is the actual one. We're going to press our calculator and make sure that your calculator is set to radian mode, okay? So then you have cosine 0.1, close bracket, and then we have 0.99500, okay? This is to phi SF, but later on when I'm going to calculate this, okay, I'm going to use the actual value, okay? But this is more for reference and illustration. Now, next up, we're going to figure out what is the approximated value. The approximated value of cosine 0.1 would be 1 minus 0.1 whole thing squared over 2, right? So we can figure this out by pressing into our calculator. 1 minus 0.1 square and divide by 2, okay? So with that, we get 0.995, which is actually pretty accurate, okay? So we can expect that the percentage error to be rather small, okay? Now, this is actually exact, okay, according to the one over here. Now, before I move on, I just want to talk about some presentation over here. Okay, you notice that I actually put a curly bracket here, or rather not curly bracket, the curly equal sign, and then equal sign over here. Now the thing is, for this, okay, over this, when we compare to this one, it is actually approximately equal. We know that this is not exactly equal to this, so this is approximately equal to this, and that's the reason why we use this, right? But we do not continue to use the curly equal sign afterwards, because on this side, okay, over here, this value is exactly equal to 0.995, and that's the reason why we keep it as an equal, okay? So note the difference, okay, and learn how to use them correctly, okay? Right, let's move back to answering this question, okay? So we're going to find out what's the percentage error. So percentage error, right, is going to be equal to, now the thing is, this is very, very close, right? So the percentage error is actually going to be quite small, but fine, it's fine, because the thing is, I'm just going to use the actual value, okay, which is going to be z cosine, okay, wait, hold on a minute, this is supposed to be cosine 0.1, okay, so I'm going to use the actual value. I'm going to key this into a calculator later on again for this guy, then minus, okay, 0.995 over the actual value, which is again cosine 0.1, okay, modulus this, multiply by 100%, okay? So let's go ahead and figure that out. Okay, I'm going to press our calculator. Okay, modulus of cosine, bracket 0.1, close bracket, and then minus 0.995, okay, divide by cosine 0.1, okay, and then times 100%. So that gives us a very, very small percentage error. It turns out to be 0.0004 0.000041 0.419%. Okay, it's very small. So as you can see, when we have x to be sufficiently small, this is actually a very, very good approximation for cosine x. Okay, the error is not even close to 1%. Okay. Now, we're going to take a look at another example. Okay, so sometimes they might actually ask you to, figure this percentage error. Okay, so let's say it's within. Okay, so the question will ask in such a way, right? So what is the range of values of x? Okay, what's the range of values of x? So let's write that down. Okay, for reference. So range. What is the range of values of x, okay, such that, so I'm just going to put st, such that our percentage error, okay, okay, I'm just going to use a capital E, is within, squeezing here, say 1%, all right, 1%, okay? So in that case, sometimes we can actually work this out, all right, by, using the formula over here. So we know that the actual value, okay, let's put the modulus down. The actual value would just be none other than cosine x, right? So we will just put in the cosine x over here. And then after that, the approximate value would be, in this case, 1 minus x squared. Okay, so when you expand, by taking out the brackets, it will be minus 1 plus x squared over 2 over the cosine x, okay, modulus, and then after that it's going to be multiplied by 100%, okay, and this has to be within the 1%, okay, all right. Now the thing is, we can actually convert all this, right, to decimals, so we don't have to deal with the percentage. So in that case, we can just use this, all right, drop the 100% and then change the 1% to just 0.01. All right, and then in order to solve this, all we need to do is to use our GC. Let's go ahead and key this into our GC and then figure it out. Okay, so using the GC, our graph looks something like this. Okay, so it looks something like this. Okay, it's very close over here to 0. And then after that, we have the 0.01. Let's say this is the 0.01. Okay, so we'll be looking at these two intersection points, right? So from our GC, we figure out that the point on the left is minus 1.05, okay, 3SF, and the one on the right is 1.05. Okay, so minus 1.05, and this is 1.05. All right. So there we go. The range of values of x as a result of that would be, okay, let's just write down the answer, okay, from the GC, right? So from GC, okay, our x, okay, to be within the 1%, the x must be in between minus 1.05 to 1.05, okay? So these are the variants of questions that you can get, okay, when they are asking you to figure out what's the percentage error, all right? So there you have it.